Today, we're going to take this really awesome pack by Cinti called the Polygon Town Pack, and we're going to update it from Unreal Engine 5.3 to Unreal Engine 5.4 by fixing the errors and the warnings so that way it uses the new, in 2022, new enhanced input system. So let's get started. What I've done is I've created a brand new project with just nothing in it, not even starter content. And then I went to my library and I just hit add to project. When you do that and you only have Unreal Engine 5.4 projects, you'll see no compatible projects are here. So to fix that, just click show all projects, and then you can choose your new game. My new game for this tutorial is called Cool Town, and then go down here and choose 5.3 and hit add to project, and then you will be where we are. I'm going to say don't add here, in this brand new map. So now this map is the demo map that comes with Polygon Towns. And if we just go ahead and hit play, you'll notice that nothing happens. I'm pushing WASD on my keyboard and move my mouse around, nothing's happening. Move my joystick around, nothing's happening. So that's what we're going to fix. So first of all, why is it broken? If we go to the blueprint and we look at the third person character, you'll notice that there are warnings on a lot of these things. And the warnings say the input action references an unknown action for input action jump. All right, well, that's pretty easy to fix, right? If you know the old way of doing the input, go to project settings and go to input. And right over here, you can add input mappings and you can add access mappings. So that's not difficult. However, you'll notice right here, it says access and action mappings are now deprecated. Please use enhanced input actions and input mapping context instead. That's the whole point of this video. So let's get to it. So what we will do instead is we're going to do exactly what it said. We're going to create some actions and we're going to create some mapping contexts. What's the difference between an action and a mapping context? Well, an action is just kind of like a control. Jump is a control. Move is a control. A context, however, is when those controls change. If you're walking, then you want to probably use the left joystick or WASD to move around. But if you're driving, then maybe W is the throttle and S is the brake. Slightly different, but on a controller, you probably want to not have this be the throttle. You probably want to have the triggers be the throttle. So in that way, you want to have, when you're driving a car, be a different context than when you're walking. So that's what these mapping contexts are. And this new, from 2022, system will allow you to do things like layers. So you can have like maybe a phone layer, and when you're walking, if you happen to have the phone object, you can push a button on the controller to answer the phone, or push another button on the controller to call an NPC. But if you don't have that, then those buttons are free to be used somewhere else. So it's like a layer on top. And you could have that same system on the driving or on the walking context. You can just layer them on top of each other. So you could have the phone and have it work in both settings. Although you probably don't want to use your phone and drive in real life. So let's look at which contexts or which actions exist in this Cinti project. So we've got jump, So that's going to be the first one. We also have looking rate, right? And this input axis turn. So turn and look, those are kind of the same thing because we want, in most games, the right stick when you turn it or the mouse when you turn it, you rotate the whole character. But then when you're going up and down, you're not rotating the whole character, you're just rotating the camera. So we'll just have all of that as one thing called look, and then move to go forward and backward and strafe left and right. Now, you might have an error at this point in the, if you just open up the context like I did, and on this particular node, and that node doesn't exist if you don't have the OpenXR plugin installed. So I checked this when I created a blank project, and that's really all of the things that I've done. So if you want to have that, then you want to have this node work, then you can have that. We are going to ignore this because we're not going to do VR for now, and I'm just going to go ahead and delete it. So let's now fix all of these other warnings up. I'm going to go to the content drawer, and you'll notice there's nothing else in here. I'm going to go ahead and create a new folder called input, and this is where I'm going to create these new assets that are used to define the actions as well as the contexts. So first of all, let's go ahead and create a mapping context. And I'm going to call it IMC for input mapping context, and I'm going to call it walking because this is going to be for all of the walking controls. We'll do driving controls in the next video. So for walking controls, when I open it up, you'll see there's mappings here, and if I press the plus on mappings, then it will open here, and I click on this none, and there's no assets. So let's go ahead and we can either create an input action here, or I'm going to go ahead and do it here. Right click, input action, and we'll do IA jump because that's the simplest of all of these actions. For IA jump, what do we need? We need it to be digital. So it's already set to digital. Digital Y. Well, you might think, oh, for jumping, I want to have like a value between 0 and 1, where if I push the button halfway, then I'll jump halfway. But Nintendo, a long time ago, they found that the timing is a lot better, and even PlayStation 2, these buttons on a PlayStation 2, back to PlayStation 2, this is a PlayStation 4 controller, but back to PlayStation 2, these buttons have been pressure sensitive, and yet you don't see that many jumping actions where like how hard you press it is how high you jump. Instead, they use the timing of it, where the longer you press, the higher you jump until you get to a certain spot, and then you let go. So we're going to do that too. Boolean for IA jump. Go ahead and save. And then we'll go ahead and add the other input actions for IA walk. I'm not going to use move because the word move could apply to a car or walking, and I want this specifically to be walking. So like forward walking and strafing. And then we'll do another one, which is IA look. And let's go ahead and look at the look one. Change this to axis 2D because we want to use both forward and backward as to tilt your head up and down, as well as left and right to turn your head left and right. So that'll be good for look. And then finally move or walk, like I just said I wasn't going to name it move. Then we'll change it to vector 2D. So we got forward and backward for translating forward and backward, and translating side to side, strafing, we'll use the other axis. All right, so now we've got all of these actions, and now we can add them to the mapping context. Now, when we click on this button here, we'll see that we can go ahead and add our 3 new input actions. Okay, so first of all, for jump, I'm going to do this the easy way. When you click on this button, it's like when you're in a game and you're remapping the controls. So I'm going to click it, and then I'm going to press spacebar on my keyboard, and there, it's added the spacebar. That's exactly what we want. There's nothing else needs to be done. Next, I'm going to add one for the game controller. So in this case, I'm just going to say gamepad, and I'm going to do face button bottom. Now, why would we want to call that face button bottom? Like, what's the difference? What is that? Is that the D-pad down? No, that's not the D-pad down. So on a PlayStation controller, right? That button is called X. On an Xbox controller, that button is called A. On a Nintendo controller, that button is called B. What? And even crazier, on a Nintendo Switch, you can take the controls out, right? And then you pass it to your friend and you turn it, and now the buttons are all messed up, right? They're all 90 degrees. So the one that was bottom before is now on the side. So that's why it's called face button bottom. I think that's a much better name. Now let's hook up walk. So let's go ahead and go here. This time we're going to do the gamepad part first. So we'll do left thumbstick 2D axis. Now on gamepads, every gamepad has a little bit of an area that is super sensitive right in the middle. And if sometimes you can even just like tilt the control just a tiny bit, and just that much will cause the gravity to pull the joystick, and that will register as a value. So how do we fix that? Well, if we go to modifiers here, we can add something called a dead zone. So we add a dead zone to that, and that will fix that. So basically, anytime you're working with a joystick, a gamepad with a thumbstick, you always want to add a dead zone. And the default values for this are 20%. So you have to move it at least 20% in order to get it to work. And I think that's fine. Now let's add the keyboard. So for the W key, we're going to have to do some changes here. Unreal uses what's called the left-hand coordinate system. So I have this terrible drawing of a left hand, but you can see the x-axis goes along the thumb, the y-axis goes along your finger, and then the z-axis goes along your middle finger into the screen. So when you think of the letters X, Y, Z, 1, 2, 3, so 1 is X, 2 is Y, and 3 is Z. Well, if we do nothing and we just have the W key on the keyboard, if you look at the way that WASD are laid out on your keyboard, W, you want to go forward, right? So that's in the Y-axis. But by default, when you add a key, it's going to go into the first axis. And the first axis is X. So what we need to do is we need to figure out how to change X to Y, because we want W to affect Y instead. So if we go to modifiers, there's a thing called Swizzle. And Swizzle changes the order of X, Y, and Z. What we want to do is make Y first. So any of these options, either YXZ or YZX, either of them are going to fix it because the button only is a single axis, the W button. So it's just going to be mapped to Y now. So let's go ahead and add D because D is right below W. Now, S. S is right below W. So now S, we want the same thing. We want it to affect the Y. So we go to Swizzle and we make sure that it's set to one of the Y ones, and it is. But S shouldn't be going up. S should be going in the opposite of up, which is a negative value. So we also need to add negate. So we have a swizzle and a negate modifier on the S key. Now let's go ahead and add A, which is the left key. And A is on the X axis, which is the first of X, Y, Z. So we don't need to add the swizzle, but A is going in the wrong direction. If you look at that left-handed coordinate system, X is pointing to the right. So pointing to the left is negative values. So we need to negate A. And finally, we'll add D. And D is on the X-axis, which is the first axis, so no need to swizzle. And it's in the positive direction, so no need to negate. And D just does exactly what we want. Now let's go to the look. I'm just going to close these like this to make it a little easier to see. Now, what key should look be? When you're using keyboard and mouse, your right hand is probably on the mouse. So we don't use the keyboard. Instead, we use a mouse, and it's a 2D axis. However, personally, I like Y to be inverted. So I'm going to go ahead and negate the axes here, but I only want to negate the Y axis. So I'm going to uncheck, after you just open up the negate options here, uncheck X and Z, only Y, and then now I have the inverted look. What about on a controller? Well, we can just say Gamepad right thumbstick 2D axis. And you could do the same thing if you like negate. I'm not sure if I like negate on a controller, a right thumbstick, but we'll find out in a second. Great, now we are done with the walking context. So now that we have all of these actions and they're all mapped inside this input mapping context, we can go back to this third-person character controller that Cinti made, and we can fix things up. So first of all, we have this turn rate and this variable turn rate. We don't have to do anything with turn rates because turn rates are how much a control is happening. If we wanted to do turn rates, we could always go into the look over here and we could adjust things by adding like adding a scalar, and then we can adjust how much the value is applied, and then we can increase the sensitivity basically. So that can all be handled by the new input system. So we don't need that, and we also don't need the lookup rate here, which means we don't need the delta, we don't need that, and we don't need this comment here. And that means we don't need either of these variables. So that's great. Now let's look at the look portion. So this says mouse input. I'm going to change this to look. It was saying turn and look up. So what we'll do is we'll change this so that we're going to right click and we're going to say IA look. And what we don't want this one that's called the action value, because if we choose this, there's no execution pin. This is the execution pin up here. So the one that we want is the event one. So IA look, choose the event one, and now we've got the same red kind of event as before. And there's a problem already, which is this is a green float value. This thing takes a green float, but this is a blue. Which is a 2D vector. So what you can do to easily fix this, right click that and split the struct pin. And now we have both of the values. We've got the X and the Y for IA look. So for yaw would be like turning your head left and right. And we want when someone moves along the x-axis on the right stick, we want it to turn their head. So X is going to go into yaw, and then Y is going to go into pitch. Pitch is like moving your head up and down like a yes motion. Now these are all mapped, so we can go ahead and delete these ones, but the execution isn't hooked up. So which one do we hook it into? Do we put it into yaw or do we put it into pitch? Well, what we can do is we can just put it into yaw and then put yaw into pitch. Now this kind of looks ugly, you might think. Why? I mean, can't we just do that with math? Well, there in the player controller, there is a property. It's a public property called RotationInput, but it doesn't have a U property on it, which Blueprint needs to be able to modify it. So the only way that we can change this is by calling the Add Controller Yaw Input, or the Add Controller Pitch Input, or the Add Controller Roll Input. So that's how we're going to do it. Don't worry, it is not a performance issue that we have to worry about. Even in C++, it just calls these two functions back to back. So no problem here. Now that is done, let's go to the jump action. So we're going to go right click here, IA jump, and we can go ahead and delete the old jump. Now we already have a problem, which is we only have one execution pin. So how do we either jump or stop jump? If we open this thing right here, then we can see that there's a bunch of different new execution pins. So started is when you start doing the jump. So we're going to do that to jump. And then completed is when you stop doing the jump. Canceled is for this press and hold kind of thing. And we don't have to worry about that. And we can close this. And now jump is complete. Let's see if I can move the comment box around a little bit. Okay, so we got look, we got jump. What is this? Touch input, and that's going to jump. Well, that seems kind of weird. How do we do that? We got touch and touch one, so this might be for like an iPad or an iPhone or something, or an Android phone. If we go to the input context, we can come over here and we can hit the plus button. We can go to touch. We can say touch one. And now we have, using configuration, done the same thing that this code did. So we can go ahead and delete all of these nodes. Great. When I zoom out of this blueprint, the only thing left is this movement input section. So let's go ahead and take this movement input. I'm on a touchpad, so. All right. Now, movement input. How are we going to fix this? Well, we've got one thing called IA move that we can use to change move forward and move right. So let's go ahead and put in IA move or IA walk. Maybe I should call it IA move because I keep calling it that. And then we have the same problem with the action value not being green because it's a 2D vector instead of a float. So let's go ahead and split that struct pin. Now, if we remember the left-hand rule, your thumb is X and your finger is Y, finger's pointing up. So we want the X value to affect the right vector, and we want the Y value to affect the forward vector. So this is in the opposite direction. So we'll go ahead and delete these two things here, and then let's put the Y on the bottom and the X on the top. Okay. Now, in this case, we can use math to only call one of these nodes. So I'm going to go ahead and delete this bottom one. Then this scale value is being applied to the whole thing. But since we're using math nodes, what we want to do is just do times. But this is now taking a vec3. So if we right click that, we can change that to a float. And so now we have the right vector, which is X, going to here. And let's multiply this one. Change that to a float. The Y vector is going here. All right. It's starting to look a little bit better. Then we need to take these two floating point values and turn them into one three-dimensional vector. So we'll just do plus. And the math works out on this because if you were in a perfect coordinate system where you're facing exactly forward, then the forward vector would be 1 on the y-axis, and the right vector would be 1 on the x-axis. So 1, 0, 0 plus 0, 1, 0 would be 1, 1, 0. So the plus operator makes sense here. We'll go and do that. And then finally, we will bring the execution pin over there. Now let's go ahead and compile and see what happens. Everything turned green. So that's fantastic. We have now fixed all of the warnings in the third person character. But let's go and test it out and see what happens. We'll hit play and still nothing happens. Oh man, why? Well, we did the actions, but we forgot to add the context. So let's add the context. When should we change the context? Well, we should change the context when someone possesses the pawn, basically. But if I were to choose possess as the action here, you'll notice that it's server only. And what we're doing is a control, which is local only. So we don't want to use possessed. Instead, what we want to use is something called event receive controller changed. So whenever the controller changes, then we just want to make sure that the input context is correct. So how do we get the input context? Well, if we look for something called the enhanced input subsystem interface, there are basically 3 different options that we can choose. There's the world subsystem, which we can see is experimental. So let's not do that one. Then there is one that is from the player controller. So we'll grab that one. And then enhanced input subsystem. The other one is the local player subsystem. Now that one doesn't have a pin. So that one seems to be the right one to pick. But it's not. So we'll go ahead and delete this one just to show that it doesn't work. And I'm going to say add mapping context, and we'll hook these together. This part on the right is correct. So we're going to change this mapping context to the mapping context walking, which is our asset that we created right here. And now all this is correct except this part. And I'm just going to show you because I like showing the problem so that way you know how to fix it yourself. We'll go ahead and hit play, and nothing's happening. And then when we get out of the player, look at this. We got a runtime error that says accessing none from a read property call func get local player subsystem. So that is that get local player subsystem thing that we just used. Here it is, get local player subsystem. So let's go ahead and delete that one. And I'm going to use the context here to get the right one. So, yep, and that's this one right here. So this is the wrong one. This is the right one right here. But this one takes something in here called a controller, right? You might think, oh, I can just grab that and put it in here. Nope. This one takes a player controller, and this is just a controller. So we need to cast it. Player controller, not a problem. And then that will work. Put this here, put this here. Put those together, push Q, put those together. Let's do it the opposite way. Now let's grab all three. Okay. And then like this. And let's add a nice comment block. This is walking context. Okay. So what about this cast failed? If the player controller, if this character was controlled by an AI, then the cast would fail. But since right now we're just dealing with actual human players playing these characters, we don't have to worry about cast failed. And in fact, it'll just do nothing in that case. Great. And also notice up here, this says client only. So if we happen to use the server only node possessed, then these two things would be in conflict. All right, let's go ahead and compile. That's there. Come back here, press play, and look at that. W is working on my keyboard. A, S, and D are working on my keyboard. And looking around is working on my keyboard. I'm going to get my controller. Uh-oh. Nothing's working on my controller. That's weird. All right, let's go ahead and escape out of the game. And now I'm going to open up just some random utility that I found. Now, you might notice from the stoplights here that I'm on a Mac. On PC, everything would be fine at this point, but on a Mac, it's not. Now, if I look over here, you can see, look, my controls are working, right? I've got X, O, square, triangle. I've got the share and options button. I've got the X or the left and right 3 buttons. I've got the triggers. Those are all working. So everything's working here, right? This is the one that makes us move forward, and this is the one that makes us move around, and that's the one that makes us jump. So if Mac OS is able to see what's going on in the controller, why is Unreal Engine not able to see what's going on? Well, let's look at the internet and look at this. Debugging gamepads on Mac OS, this user from 2020 said that they could get their thing working in HTML5 gamepad, but not in the editor. Then this person, they said, same person actually. Then some more people, they also had the problem, and there's no fix yet. August 2020, 2022, it's been quite a long time and it hasn't been resolved. Wow, a lot of people seem to be having problems with this, but this guy, which is me, just figured out the solution. So the solution is what you need to do is to go and open up your DefaultEngine.ini file. So this is in Cooltown here. And add something called SystemSettings, Slate.MacControllerPreferGCImpl 0. I had to look into the source code to find this, so there's no other place on the internet except this thread that shows you how to fix this problem. What we're going to do is we're going to hit save. We're going to close Unreal Editor. Then we're going to open it up again. Cooltown.u project. There we go. Now you'll notice that that's not it. Yeah, sure, let's reopen those. I was going to say, you'll notice that it detected the controller. It did detect the controller before too. And I'll show you that in a second. And that's not from this fix. It would detect the controller before. So I'm going to unplug my controller. See, input detected is disconnected. I'm going to plug it back in again. Now it's connected. It used to say that before this fix, but now with this fix, it's using the old system. When I hit play, now it's working. Look at that. Yeah, okay. That feels opposite. I said we were going to look at that. So that feels opposite. Let's go ahead and fix that IA look, or over here IA look. I'm going to do the gamepad, and we're going to change this to mirror negate the y-axis. We'll save that. We'll hit play. Let's try that again, see how that feels. Okay, yeah, that feels a lot better to me. Great, so this is basically done with the warnings. There's one more warning, which you've probably been screaming about. That's right here. It says that there's a bunch of extra lights. We can go ahead and disable that light, and we can disable that light, and this one looks like it is the wrong one, so we will go ahead and delete this one, and now that warning goes away. And in fact, let's go in here, and 11 lux, I mean, it seems like it's the middle of the sunshine on the moon, so let's try, or not on the moon, but on the sun. There we go. I just set it to 2.9, and looks pretty good at 2.9. I don't know. Your results may vary. You can adjust the lighting however you want. But now we have adjusted. This demo is totally playable. No more warnings. And it works with the controller, works with the mouse, works with the keyboard. But this town is a little bit dead. There are all of these cars. Oh, look at that. Yeah. I'll talk about two things. I've just thought of something. These cars, and you can't drive them. So that's what's going to be in the next video. Now, right now, I've got some drift going on. And remember what we do to fix the drift? What we do is we go to, whenever you have a thumbstick, always add the modifier. Yeah, we don't have the modifier for, here it is, the dead zone. Anytime you have a joystick, always put a dead zone. That was a case in point right there. Now look at that. No more drifting. It's holding steady. That's great. All right, see you in the next one, and we're going to hook up the vehicles with the Chaos vehicle system.